So good evening to one and all. Good evening to one and all. Today we are going to discuss about collision theory. Collision theory of reaction rate. Collision theory of reaction rate. Actually, collision theory was proposed by Max Troj in 1916. It was proposed by Max Troj in 1916. And also, same this concept was proposed by William Lewis in 1918. William Lewis in 1918. What are the main points of this theory? What is the purpose of this collision theory? Simply, collision theory, a chemical reaction takes place. Collision among the reactant molecules. What is chemical reaction? Whenever a chemical change occurs, it has a chemical reaction takes place. The reactants can be converted into products. The original substance can be converted into new substance. It is called chemical change. Whenever a chemical change occurs, chemical reaction, it has takes place. The main points of this theory, a chemical reaction takes place due to collision among the molecules. A chemical reaction takes place, collisions among the molecules. Collisions among the molecules. That is the first point. And second point is the number of collisions takes place per second per unit volume of the reaction mixture is called collision frequency. The number of collisions takes place. The number of collisions taking place per second per unit volume of the reaction mixture is called collision frequency. This collision frequency is denoted by symbol is Z, capital Z. I hope it is clear. Second point. Like that, various points are there. And another one is the value of collision frequency is very high order. The value of collision frequency is high order, 10 to the power of 22 to 10 to the power 10 to the power of 25 to 10 to the power 8. This is a very high value in the binary collisions. The value of collision frequency is a high order, 10 to the power of 25 to 10 to the power of 28 in binary solutions. Every collision does not bring a chemical change. Every collision does not bring a chemical change means every collision does not lead to the formation of a product. Every collision does not bring a chemical change, that means it does not produce products. And that is the fourth point. You can observe here. Another one is every collision does not bring a chemical chain. That means all collision does not lead to the formation of a products. There are two types of collisions are there: effective collisions and ineffective collisions. The collision that actually produces the products are effective collisions. The which collisions reactants can be converted into products, then the collisions are called effective collisions. These collisions are classified into two types: effective collisions second one is ineffective collisions. Okay, ineffective collisions. Okay, for the collision, for the collision that not the collisions that do not form products are ineffective collisions. In ineffective molecule, the molecule just collide, and that means disperse different directions and different velocities. The molecule just collide and disperse, different directions with different velocities. In ineffective collisions, the molecules just like that collide and disperse with different directions, and different speeds. This ineffective collision does not produce products. That means here once again repeat, the collision that do not form a product or ineffective collisions, the molecule just collide and disperse with different directions of different speeds with different velocities. And whereas for a collision to be effective, the collisions to be effective, there are two conditions are there. The first one is energy barrier, and second is orientation barrier. These two conditions are required. The reactant molecules can be converted into products. For a collisions to be effective, energy barrier and orientation barrier to be cleared. So these are the main points of collision theory. Okay, what is energy barrier? What is orientation barrier? We will discuss one by one. Energy barrier. You can observe in energy barrier, fraction of molecules in energy, x-axis, y-axis. Okay, this is a fraction of molecules. This is called energy on x-axis, fractional molecule of the on y-axis. You can observe here. That means here this is a reactant, this is a product. Fraction of molecule capable of bringing effective, fraction of molecules bringing effective collisions, capable, fraction of molecules capable of bringing molecules, capable of bringing molecule. The minimum amount of energy is required. The minimum amount of energy is required. The minimum amount of energy which the colliding molecule must possess the minimum amount of energy, which the colliding molecule must possess as to make a chemical reaction that minimum energy. The reactant molecule should possess minimum energy. That minimum energy of reactant molecule is called threshold energy. Threshold energy. It is denoted by the symbol ET. What is threshold energy, sir? The minimum amount of energy which the colliding molecules must possess. The minimum amount of energy which the colliding molecules to make a chemical reaction is called threshold energy. There is energy barrier for a reaction, for each reaction. The reacting species must be provided with sufficient energy so as to cross the energy barrier. The minimum amount of energy required by reactant molecule to participating in the reaction. Activation energy, threshold energy is equal to activation energy plus energy of reactant molecule, normal energy of the molecule or energy of reactant. And one more energy, activation energy. The amount of energy is required, the minimum amount of energy is required by reactant molecule to participating in the chemical reaction is called activation energy. The amount of energy is required by the reactant molecule to participating in the chemical reaction is called activation energy. It is denoted by symbol EA. Activation energy is equal to the difference of threshold energy minus average of kinetic energy. Activation energy is equal to difference of threshold energy and average of kinetic energy. I hope it is clear. Threshold energy is equal to activation energy from energy of the kinetic energy of the reactant molecule, simply. Okay, this is information about energy barrier. Another one is orientation barrier. What is orientation barrier, sir? Energy alone does not determine the effective collisions or fruitful collisions. Energy alone, that means energy is only energy does not produce reactant, can be converted into product, but not produce effective collisions. Energy alone does not determine the effective collisions, effectiveness of the collisions. The reactant molecule must collide to be in proper orientation. That means in proper manner in the order to occur the reaction. That means here A atom, B atom, here also B atom. Proper orientation, improper orientation. This is the proper direction, orientation of the molecule. That means here bond making, bond breaking, here bond making between A atom and B atom, bond breaking between A atom and A atom. And also if you take one more direction here, A, B, that means molecule, this is covalent molecules. Improper orientation in this direction. This is proper orientation. Improper orientation. Here This proper orientation, bond breaking and bond making takes place. Now I am taking this is only, that is a proper orientation you can observe here. Between these two, bond breaking, between these two, bond breaking. Here bond breaking, here bond making, to form final products, that is A atom, B atom, A atom, B atom. It is a reactant starting material. This is called reactant. This is product. A reactant can be converted into product. Intermediate stage is there. That is called transition state. It is also called activated complex. Here kinetic energy is maximum in reactant side. Potential energy is minimum. In product side, kinetic energy is maximum. Potential energy is equal to minimum.